Atlantic team. I'm Bahurel and I'm working at Mercator Ocean International. I will be chairing the first session of today's meeting. The participation of this regional team is vital for OceanPrediction DCC, since it is a very well-structured community via Eurogoose. However, OceanPrediction DCC could provide an additional layer to this community by establishing connection with other regional teams from other parts of the world. I'm going to start by sharing the agenda and presenting the three sessions we'll have today. So the first session will be an introduction of OceanPrediction Decade Collaborative Center and this particular Northeast Atlantic regional team. The second session will be chaired by Loreta Cornacchia from Deltares and will be about a mapping of present-day situation of ocean operational forecast system and the impact on blue economy. And the last and third session will be an interactive session that will be chaired by Enrique Alvarez Fanjul, and it will be an open discussion and interactive session. So the meeting will be recorded, and the two first presentation will be made by video I will share. And if you have any question, you can share them in a Q&A box, and we'll have time to answer all those questions during the question and open debate session. I'm going to share the first presentation with an introduction of the context of the decade by Alison Clausen from the Intergovernmental Oceanographic Commission of UNESCO.
So good morning, good afternoon, good evening to everybody. For those of you who don't know me, my name is Alison Clausen. I'm a program specialist at the Intergovernmental Oceanographic Commission of UNESCO, and I'm also the deputy coordinator of the UN Decade of Ocean Science for Sustainable Development. And I'm thrilled to welcome you all here today for this regional meeting for the Decade Collaborative Center for Ocean Prediction, which is so generously hosted and supported by Mercator Ocean International. I just wanted to give a few opening words about the decade as a start, where it came from, why we've embarked on this adventure, but also really the importance of ocean prediction and the particular importance of this Decade Collaborative Center within the decade. So the Ocean Decade, as we fondly call it, was really born out of the fact that ocean science and ocean knowledge are central to so many facets of sustainable development. If we're thinking about food security, if we're thinking about education, resilient cities, if we're thinking about renewable energy, ocean science and knowledge is needed for all of these facets of sustainable development. And the decade, which started in 2021, is now entering its third year of implementation. And I think this centrality of ocean science and the need for relevant and timely science and knowledge on the ocean is really greater than ever. But the opportunities are also greater than ever. You know, last year it was called the Super Year of the Ocean. There were numerous global conferences and meetings and convenings. This year there have been incredible advances in terms of new agreements and advances on the negotiation of a treaty around plastic pollution, around biodiversity in areas beyond national jurisdiction. And there's, I think, a really strong and growing awareness of the importance of the ocean for climate, for biodiversity action, and for human health and well-being. The work of the high-level panel for a sustainable ocean economy has really encouraged governments and other partners around the world to to really start acting and develop tangible and actionable commitments and engagements to sustainably manage the ocean. So the Ocean Decade is part of all of this. It's part of these opportunities. It's really a rapidly growing global movement that's playing an increasingly important role as the engine of ocean science and ocean knowledge to feed these initiatives. For those of you who know it, I'm sure many of you do, the vision statement of the Ocean Decade is the science we need for the ocean we want. And the decade is structured around 10 Ocean Decade challenges, which range from marine pollution to ecosystems to the ocean climate nexus to sustainable blue food, but which importantly also look at some of the key pieces of infrastructure, the Ocean Observations Network, looking at digital infrastructure, the pieces that we need to be able to meet some of these big challenges. And of course, ocean prediction is really central to all of this. The Ocean Decade has grown rapidly since it started, which, as I said, was in 2021, and it's really been wonderful here at the IOC of UNESCO, which leads coordination of the decade, to see that growing momentum. There are now 48 global programs. We just had our 48th program endorsed. They're working across all 10 decade challenges across all ocean basins. But there are still notable geographical gaps in leadership. There are challenges in getting skills, access to partnerships, access to data, access to technology in least developed countries and small island developing states. And that's why, one of the reasons why we applaud this initiative of Mercator through the Decade Collaborative Centre to set up these regional hubs, because it's so important to be able to translate the global ambition of the Ocean Decade to the regional level and start filling some of these geographical gaps that we're seeing in the decade ecosystem. So these 48 programs, we also have close to 300 projects now. And if we're going to achieve the stated aim and vision of the decade to have the ocean we want by 2030, we're going to need massive amounts of coordination to ensure that we really are having a collective impact. And from the outset, the Ocean Decade was structured within UNESCO to have a very light and central coordination structure. But the aim was really to rely on partners with deep thematic and regional expertise and networks to take the decade to a level where impact could be achieved. And Mercator Ocean International was one of the first partners to rise to this challenge via the establishment of the OceanPrediction Decade Collaborative Centre. And I think it's fair to say that Mercator has really become a model for others to follow through the innovative approaches that they're using to regional engagement, community creation, knowledge sharing, catalysts of partnerships. And IOC UNESCO and the Decade Coordination Unit sincerely thanks Pierre, Enrique and the whole team for their leadership and engagement in this regard. Now, Mercator is not alone. Other Decade Collaborative Centres, Decade Coordination Offices have been emerging. We now have Decade Coordination Offices focusing on ocean observing and data sharing, and both of these are actually housed within UNESCO itself. And so in this way, the Ocean Prediction DCC of Mercator is really able to play an even stronger and more impactful role by working with these other Decade Coordination Offices along the whole ocean science value chain. 2024 is going to be a critical year for the decade. It's going to come fast. We're already very, very close to midway through 2023. The 2024 Ocean Decade Conference is going to be a seminal moment for the decade. It's going to take place in Barcelona in April, from the 10th to 12th of April 2024. Pre-registration has opened, as has the call for satellite events. So have a look at the Ocean Decade website and find out more. And that Ocean Decade Conference, of course, is going to be an essential part of the preparation for the 2025 United Nations Ocean Conference. With the support of Mercator, the DCC and other partners, we hope that the ocean forecasting and prediction community is going to be able to really seize these opportunities, these events, these major global convenings that are coming up, to grow and to continue to catalyse new and innovative partnerships and sustainable development solutions. So having these discussions like today at the regional level is going to really ensure the relevance, the uptake of the results. And this meeting is so important. I wish you all wonderful discussions. I wish I could be there with you in person, but unfortunately I'm travelling and I'm committed elsewhere. But I really look forward to continuing to collaborate in the framework of the decade with the team at Mercator, with the Decade Collaborative Centre, and with all of you to collectively achieve the vision of the Ocean Decade for the ocean we want by 2030. Thank you very much.
Then the second presentation will be made by Pierre Bahurel, who is the General Director of Mercator. And I'm gonna share this presentation. And then I promise all of our presentation will be made by people who are able to connect with us today.
Dear colleagues, dear friends of Ocean Prediction, I am Pierre Bahurel. I'm the Director General of Mercator Ocean International, which is the organization that has been entrusted by IOC UNESCO for the implementation of Ocean Prediction DCC. I'm fully convinced that this is timely, this is necessary to deliver as one community, worldwide community for ocean prediction. And we were ready with Enrique Alvarez Fanjul, the technical coordinator of the DCC, to fight for this, to work with you. But we were not prepared to receive such a response from you, from the community, about the appetite for doing more. So yes, we will do that. I have the feeling, and more than that, that there is something happening in our community of ocean prediction. Political leaders, they have decisions to make for the ocean, and they turn to us. They are looking for the data, they are looking for evidence, they are looking for this digital oceanography, the modeling, the prediction, to explain more. And we are there, and we are ready to deliver. And we are more impactful than we think, and more organized than they think. So this is exactly what this Ocean Prediction DCC is about. Organize our community, make it clear, visible, and impactful, and be ready to deliver as one at the end of the decade. But we will do more, and every year we will deliver, and we can trust Enrique for this, to steer our group to really deliver. And this year we want to deliver two things: a map and a plan. A map to put each of us on the map and be able to identify who is where and what are the best practices for your region, to share them with the other region. And the plan to explain what we want to do all together, the standards, the technical background that we want to share, and how we will deliver as a community. A map and a plan. And something which is very important is that this Ocean Prediction DCC is a collaborative center. It means that this is a bottom-up approach. We will work from the programs of the UN decade, this fantastic momentum that has been creating with programs that are gathering the projects and the actions. So we will play with the program leaders and the teams to identify what is mature to organize this community. And we will play with the regions, with your region, because we do believe that the best experts in your area are you. So we want to understand from your region what can be shared with the others, how we can work together to deliver as one in this Ocean Prediction DCC. So I wish you the very best for this meeting, and trust Enrique for the rest of the meeting. Thank you very much.
Well, trust Enrique for the rest of this meeting. So please, Enrique, we trust you for a presentation of Ocean Prediction DCC.
Let's start checking if I know how to share my screen. So hopefully you are seeing now my screen.
Yes.
I have to switch, I guess. Here we go. So
yes.
I guess it's correct now. So thank you very much, Barbara, for this introduction, and thank you for the perfect introduction to the meeting. So I would like to explain what is Ocean Prediction DCC about, and especially I would like to highlight the importance of the regional teams and why these are so important and how they are configured, how we pretend to work with them. So first of all, a little bit of explanation, on where we are in the framework of the decade. There are two main blocks in the decade, as stated in the decade implementation plan. First, there's a block about governance and coordination, And here's where you can find the decade coordination unit, which is IOC. Alison, that was speaking at the beginning, is working here on the decade coordination unit. And then we have the different, as Alison explained it, Mercator is not alone. There are other DCCs and DCOs. For the sake of this presentation, they are the same kind of animals, so it's not very big difference, DCCs and DCOs. So we have these bodies that are in charge of collaboration, monitoring, and coordination, the actions of the decade. And the most important part of the actions are the programs. Each program will have in the future different projects. And you have here very well-known names such as 4C, DITO, PostPredict, GEMS, Ocean. So these are the programs that will be, let's say, the development force of the decade. So the role of this layer here is try to promote coordination, try to promote collaboration in order that these programs work in a coordinated way and develop things that in the future will survive the decade and will be more important than the decade itself. So this is our position in the framework of the decade. If I have to summarize in a single slide what we pretend to do, this is the slide that summarizes the idea. This is the ocean forecast we have today. We are proud of the systems that we have. We have been working on these systems for the last 20 or 30 years, and they are quite useful, but we have to admit that they are somehow technically disconnected, and they are difficult to manage, to operate, to implement. So there's poor presence of this system in countries that are technologically less advanced. Our intention in the framework of the decade is to change this scenario to a new scenario where we have many more systems available, more robust one, using common tools, standards and best practices, and work it integrated into our community. So the final scenario will have this community, and we will have many more robust systems providing data for decision making. So how we are going to do this transformation? First of all, the captain, the opportunity, big opportunity here is the UN Ocean Decade. Obviously, the dedicated action of the programs that I mentioned before and the arrival of the concept of the digital twin are going to be of paramount importance to deliver all this. The crew is this community that we are building, and this regional team is about building this community, as you will see on next slides. And the role of OceanPrediction DCC is just to serve as inspiration from one scenario to the other one. So we are setting the course. We are, let's say, in this analogy, the navigator on this process. So we have basically two pillars. Most of my presentation today is about pillar number one, which is the community building. I will talk at the end a little bit about pillar number two, which is the technical pillar. But today it's about building the community, and in particular, building the community in the region number 5, Northeast Atlantic. So we are building this community through the regional teams. Regional teams are geographical divisions of the world of the ocean that we have set up. They can be discussed if they are the best ones or are not the best ones. They are quite, could be different ones, but we choose this one. We didn't want too many to keep it under control, the whole thing. And these regional teams will be promoting the implementation and use of ocean forecasting systems worldwide. In other words, we cannot easily reach India. We cannot easily reach South America. So we need these regional teams in order to have our voice represented there. So these regional teams will be our boots on the ground for actual work. The first part of the work is to identify and attract this community. This community that we want to build is not the classical community. It's not only scientists. It's not what we have been traditionally doing, for example, in the framework of Eurogoose or in the different regional alliances. But we want to attract, to be more active, attracting users, private sector, non-governmental organizations, etc. So we want in this community everybody talking to each other and learning from each other. Obviously, these regional teams will be there to support decade action related to ocean forecasting. This is in the DNA of OceanPrediction DCC. And then we will work in identification of gaps and way forwards. We are in fact already doing that in the framework of the technical part of the DCC. We will work on capacity development, and we will advocate for implementation of best practices, tools, and standards that we are at this moment trying to define. So how we are going to implement this? Okay, for each region, we have prepared some terms of reference. Some regions prefer to call this like collaboration plan. It's not a big deal, the name that we are putting to this document, but this document expresses basically the organization and the governance of this regional team. And we have fundamentally 2 points. First, a regional focal point, which is a chair, a person, plus an institution. And then we have a steering team, which is always a set of experts on the same topics. So we got observation, physics, biogeochemistry, climate, efficient, the same topics in every region. So once we have these steering teams formed in every region, we will have a network around the globe that will be able to talk to each other and to do all the things that I already mentioned, such as promoting the implementation of commonly agreed tools, standards, and best practices. So these are the 2 key elements. Remember, a focal point and a steering team. Where are we in the implementation of this around the world? Well, we started quite well with the kickoff meeting because, as Pierre said, that demonstrated the appetite of the community for this idea. We had also 1,800 people registered for the kickoff meeting. And this is the situation where we are today in building these regional teams. These are the different steps that we consider are needed to create a regional team. First, finding a chair. This is already achieved in all regions. Then building up the contribution to the technical pillar, which I have not explained it yet. So these regions can contribute to the technical part of the DCC. Then we are updating the tour to the desires of the chair and the desires of the regional team. So we tune it to fit the needs of the regional teams. Then the kickoff meeting, which is today for the Northeast Atlantic. And then finally, the last step is to have these teams ready, these teams with people willing to work in these different aspects on place. So this is where we are today. And the objective is to have, by the end of the year, the whole thing completed. So we can start next year really operating with this structure. To give you some samples of where we are, those are the different chairs that we have around the globe. Very good names, very representative institutions here. We have Swadin from Jamstec and Japan from the West Pacific. On the India, we have INCOIS, which is the most powerful institution there. On the African seas, we needed several co-chairs to cover the different variety of coasts and also the different cultures and different levels of development in Africa. In the Mediterranean, Black Sea, we are doing something very similar to what we are doing in Northeast Atlantic. We have trusting here on the mongoose, and it is Emanuela from CMCC. And the Northeast Atlantic is Ghada as chair of the Coastal Working Group of Eurobus. Region by region, the steerings are being assigned. These are the most advanced ones, the ones in Asia, in Indian seas, on the African seas. You can see that the names are popping up and we are building this. Sometimes we have just one name per category. Other teams have preferred to use in order to include more variety. That could be also an option for Europe in order to cope with the different regions in Europe. To have more than one per category if desired. So this is very much up to the regional team organization, to the chair and to the organization that is going to be. That's what we are going to discuss today, I guess, during the open session. So once this regional team will be in position, these experts will be very important for the development of this initiative because they will act as focal point in the region for the particular topic they are dealing about. They will network with other experts from other regions. Of course, they are here to provide new ideas, to give new steering for the Ocean Prediction DCC, so we can gather new ideas and we can build on the ideas of the experts of the steering team. Then some very particular tasks like support the mapping of ocean forecasting, gaps and need detection activities. Very important, help us with the communication and the forum that we are building. These three ones, the mapping of the ocean, the communication and the forum, and the capacity development are going to be showcased in the presentation by Romane later when she will explain the different tools that we are building around our webpage on the Ocean Prediction DCC. So these are the roles of these teams, and the idea is that they work together with the other steering teams on the other regions, building this worldwide community. So why Eurogoose Coastal Working Group was selected for this role? Well, Eurogoose Coastal Working Group is doing a fantastic job in developing state-of-the-art science and application at coastal scale. So we consider that it's not a good idea to come with the OceanPrediction DCC and reinvent the wheel. This is a structure that is there, and what we believe we can do is to provide an additional layer thanks to the OceanPrediction DCC to this structure. So instead of creating parallel structures and duplicating things in a stupid way, if you allow me, then what we are doing is providing an additional layer to the Eurogoose Coastal Working Group, empowering this Coastal Working Group and using it for core of the OceanPrediction DCC regional team at Northeast Atlantic. Why? What are the advantages? You can see here a list of the advantages. First of all, it will provide to Eurogoose a participation in the structures of the decades in a natural role for Eurogoose, which is the coordination layer of the decade. Remember my first slide, where we are located in the decade. Then we are helping Eurogoose to connect with additional sector beyond our traditional science community. Remember that we want to create this transversal community, including users, including the private sector, etc., etc. Then we will provide tools via our webpage, this atlas, the forum, that could be used by the Coastal Working Group to enhance the work. Especially the atlas will be, I think, very, very helpful. And we are in fact preparing this atlas from day number one in close collaboration, both with Eurogoose and both with Mongoose. So the statement of work for this atlas was prepared with collaboration of Eurogoose, collaboration of Mongoose, and the outcome, this atlas will be available for the Eurogoose webpage and will be available for the Mongoose webpage. Then it will serve to establish peer-to-peer connection with regional teams on other parts of the world, which is a value by itself. Then will serve to advance on the technical development via common grid architecture for forecasting services. This is what we are working on our technical pillar, and participate in future activities for capacity development. So to finish this, a few words on this second pillar, which is the technical one. I already talked about these problems of the systems between brackets, technically disconnected. So you can see this when developing a new system. You need basically to read a lot, to do a lot of research. You're starting very much from scratch. And then when you finish, you don't have common tools for validation, dissemination, and exploitation. You have the risk of finish like an isolated system. So the opportunity is dedicated here as a game changer. And we want to build this new scenario that I commented by harnessing the UN decade and the digital twin opportunities. And the first step we have done in this direction, and this is already working. We are in the middle of this work. In fact, today we submitted a first paper as an outcome of the work of this group. It's the Ocean Forecasting Co-Design Team, which is a group of 40 international experts. There are many of them today on this meeting that will design a new architecture with standards, tools, and best practices in cooperation, of course, with related decade programs such as 4C or Cost Predict or others. And this will inspire dedicated programs developing targets in the following years. So this is the Ocean Forecasting Co-Design Team, and this is what we pretend to do on the following years. So to summarize, OceanPrediction DCC is a key element for the ocean prediction we need. It will build on an active community of users, scientists, and policymakers. And we will take advantage of obviously of the decade framework and of the arrival of the digital twin to build this new ecosystem to deliver us one worldwide. Collaboration with sorry about it, this will be Eurogoose modeling. Eurogoose Coastal Working Group is a natural approach because it's not reinventing the wheel on the technical side, as I mentioned it. The Coastal Working Group has been done and has demonstrated a fantastic capability to do this technical work. So we don't want to create a parallel thing. It will make no sense at all. But we will expand these capabilities of the Coastal Working Group, as I explained it previously, and we will contribute to improve the position of Eurogoose in the decade through this activity. So this is all on my side, and I will be later delighted to ask any question you might want to leave on the chat. Thank you.
Thank you, Enrique. For the next presentation, my colleague here in Mercator, Romane Zufic, will present OceanPrediction DCC tools.
Thank you, Barbara. Hello, everyone. Indeed, I'm working with Barbara and Enrique to support ocean prediction, and I'm acting as a capacity development officer at Mercator Ocean International. Let me just share my screen here. So I will present the future websites of ocean prediction and what would be the tools. Enrique mentioned most of them, but I will go into detail a bit. So this is just the mock-up that you can see on the side. This is the homepage. So the website will be officially launched in September with kind of a silent launch in July, just for us to grasp all the website and be ready for the main launch when we will have all the tools available. The tools I meant by these, the Atlas, the forum, the news corner, and event as well, and the resource page, among which the EATIP guides that would be turned into a wiki. And our objective overall for this website is really to be the place of exchange for the community of ocean prediction, because we say that we aim to connect the world around ocean forecasting, but then all these community needs a place to exchange, a place to learn from one another, a place to know each other. So this is really our goal here, because unfortunately we cannot make so many in-person events. So this is really our place to gather everyone. So first, I mentioned a place to meet everyone. So this will be the Atlas to really identify our community. So we will have 4 different atlases actually. One putting on the map the operational ocean forecasting system. One giving a directory of individuals, one of institution, and one for downstream services. The idea is really to have this as a source of information for all operational ocean forecasting system activities, a way to find partners, a way to find institutions. And really, this interface is meant to be able to give the community the possibility to add the information, to modify, to visit each other's profile once we are registered, and to link one institution to its operational ocean forecasting system. As a person, you will be able to add yourself to your institution as well. So it's really a place where we should understand how the network is organized. And as mentioned by Enrique, this Atlas will be really embedded on the Eurogoose website. So it's really also meant to be a tool that will be useful for everyone and that will be shared among the community. So here is just a short preview. Again, it's mock-up. It's not really exactly how it will look like, meaning by that the dots are really imaginary at the moment. But you have a preview here of the forecasting system map. So the dots are aligned according to the size of the system. Of course, we don't see at the moment the global one, otherwise the dot will be very big, or maybe all the map actually. So the dot is centered on the center of the model, and we will be able to have a filter on the side to really see the one we aim to look for. So with geographical sectors, but also the organization that is implementing it, etc. Here we have a short preview also of the individual map. Again, we don't see on the side, but we have filter again. And here on the right part, you can see when you ask for the list, you can see the person here. And on the next slide, you can see if I'm clicking on someone either on the list or on the map, I have this window, pop-up window coming. And this is the info that we will know about each other's. So that will be the location, the regional interest, the subject, the position, the degree, and some bio that the person will have filled, and also the website and LinkedIn profiles. Again, everything is on a voluntary basis. Then we will have a place to exchange. That will be the forum. It will really be the focal point to communicate. We will have different channels, including some matchmaking, some opportunity sharing, some community announce, we will have also a place dedicated to the regional teams. So that would be the regional forums that could be administrated by the regional team if it's necessary or if you're relevant. We will. This is something that we need to adjust according to the regional teams. We will also have technical forums for special announces or job solving. For example, we plan to have a technical forum for each model. So this is an example. Here you can see here on the left bar here all the different channels that we imagined, and here is a preview again of how it will look like. So it's you can reply, and we will have like a normal forum after this. Then this is the news and event corner. So we really aim for this to keep it to keep the community informed, whether informed about the regional team activity, informed about the decade action, also other special news and announcement that we can imagine. And again, this is really a place where we aim to have the regional team being involved, sharing with us some of the present news. So we will really try to have this as much up to date as possible and as much transversal as we can. And that, as mentioned, is on the resource side. We will have the EATIP guide that will be converted into a wiki. So the idea is for everyone with expertise to come and edit the EATIP guide that will be submitted to moderation. And the idea is to have a consolidated version being published every 3 to 4 years with the additions that have been put on the wiki during these 3-4 years. For example, the first thing that we will try to achieve is to add a new section on biological modeling and tsunami. And we really also aim for having improvement in several sections, for example, having a river contribution as well. So it will really be a place to grow as a community as well here, to have this reference document growing over time and staying up to date. And last, if you attended the kickoff meeting in January, you may remember that we had exhibition halls. We will really take these exhibition halls and put them in the website as well. So we aim to showcase the partner through these virtual halls. So we will have an exhibition place for operational forecasting system, one for downstream services, and one for decade action. This also will be up to date according to everyone's every system for every institution updates. But the idea is really to have this place to showcase all the activities that are happening. And I guess that's it. That's already kind of a lot to launch a website. So we will aim to have this really ready by September for everyone to see and to try it and start using, hopefully. Thank you very much.
Thank you, Romane. If you have any question about Enrique or Romane presentation, you can use the chat box, and we'll have time to answer your question. Now I'll give the floor to Ghada El Serafy.
So hi everyone. Good morning, good afternoon, or good evening. I am trying to share the screen first of all. Can you see my screen?
We can see your screen,
but not slideshow. Now slideshow?
Yes.
Okay, perfect. So this is Ghada El Serafy from Deltares, and I'm the chair of the Coastal Working Group, and I would like very much to dive a little bit into the technical pillar that has been talked about, and really based on the work that we have been doing in the Uruguay's Coastal Working Group, to shed a little bit of light on what is the vision of this working group, and then how can we embed our work into the DCC and enhance this with the communication to the community. The work is based on the work of the community that we have, whether it's in this region or any other regions. However, now we are going to enhance it for that region and not also, disregard the communication with other regions. This is part of the DCC Collaborative Center. So let me share the idea that we have in the Coastal Working Group. So it is really an easy access to predictions and forecasting that would enable the community to expand the knowledge and allow the policymakers to take scientific-based decisions with a stronger science policy interface. This is what we have been doing for the last actually couple of years, maybe 6 years to 7 years, and we are trying to enhance that across regions and to port the work that we have been doing and enhance it in a new collaborative center, which is the Decade Collaborative Center. Let me explain the technical part. I don't know if you are seeing my mouse. So can anyone say yes?
Yes.
Okay, thank you. So this is the data. Let me explain the flow of this service. What is an information service or a sustainable service? That is based on the flow chart, and let me explain that. So up there is this data providers, whether it's remote sensing or any kind of data that is required by the forecasting capability of our models. We have to digest that in a data processing cloud computing type of acquiring and transforming, and to be able to do a forecasting in an operational system, then we have the models and we have the forecast and the prediction, enhanced, of course, with data assimilation and fusion, uncertainty information, etc. All of that to feed into services that is based on a user identified needs and a user identity, and would like to have the information in a specific way posted. So actually the co-design that Enrique was talking about, this is really the co-design with the user and with the community to be able to provide this forecasting prediction and forecasting information. So I would actually highlight this part of the forecasting and the prediction and how can we enhance that. Our ways forward, actually, and this is really from the Coastal Working Group, but also all other regions that we have been communicating with, they would like to enhance the prediction in so many ways. And I simply posted some of them, like the ensemble forecasting, including the dynamic downscaling from the core services, data assimilation, uncertainty analysis, even stochastic way and time series analysis to be able to cope with the climate change and the effect of the climate change. So those are just topics that we have been working on within Eurogos, but the idea is, of course, to enhance that with this community. So I'm mainly focusing now on the technical part, but this is a starting point to collaborate with the others, of course. Going through this, so as you see, I mean, those are just examples of how can you identify an uncertainty limit and how can you do a prediction that matches the observation, how can you validate your model to be able to do those things. This is an embedded expertise and knowledge within this community. And this is nothing new. What we are trying to do here is actually collectively work together to build this community and to be able to improve, as has been said in so many instances today, to improve our capability to provide prediction and forecasting with a proper uncertainty bands, with a proper scientifically based information that can serve the community, society, and policymakers. So this has to be very highlighted here. I would like to conclude my remarks by saying those are the objectives of our team. And in my opinion, this is a vision that we are setting, has been already the vision for so many of our groups, initiatives, and individuals within this community. And this is the right moment to have a collective vision forward. And this will not happen unless we are sharing this vision together and we are sharing the knowledge and collectively working together to be able to go forward and have our future ways forward. So I would like very much that you are commenting on the ways forward, that you are part of this knowledge collectively working together. And please provide your name to be part of the steering committee, because it's only then we can go forward and provide access, easy access to our prediction and our knowledge, and enhance our knowledge and serve society. So thank you. Any comments? So Barbara, I'm back to you to collect comments and to collect actually questions for the whole presentations that have been posted today.
Thank you, Ghada, for your presentation. Enrique will be chairing starting from now, so I give him the floor.
So thank you, Barbara. I can see that there are a few questions, and we will try to do 5 minutes of questions now, then 5 minutes break, and we go into the presentation. So we will do a very short break. The first question is Sebastian. Thank you very much, Sebastian, for this question and comment. The Eurobus Coastal Working Group has two limitations to represent the Northeast Atlantic region. First, some of its members come from Mediterranean countries. I don't think really this is a problem here, as long as the members are dealing with issues on the region. And in fact, this is I will say we are very lucky in this region, because it's a quite well limited region. For example, when dealing with Indian seas and African seas, the frontier where one starts and the other starts is obviously not clear. So we are somehow trying to connect both ones with a figure that we have implemented on those regions, which is kind of ambassador of one region in the neighboring one. I don't have the feeling this is needed here, but maybe this is you can consider this is different, and we can try to connect the Mediterranean and the Northeast Atlantic in this way. But to be honest, I don't think this is needed, because the frontier is very clear on the Straits of Gibraltar. Then not all the countries from Northeast Atlantic region and not relevant institutions involved in OceanPredict in the Northeast Atlantic region are represented in the Eurobus Coastal Working Group. How will you handle these two drawbacks? So the first one I explained it. I don't really think this is a drawback. And the second one, I think this is more an opportunity than a drawback. This is correct. Not everybody is on board the Coastal Working Group, but this is precisely what we are trying to provide to the Coastal Working Group through these initiatives, the possibility to expand to a wider extent together with the OceanPrediction DCC, and to include other people that are not today. Other people, not only from institutions, but other people from different sectors, remember. And that will take time to us, because when we do a meeting like today, we tend always to finish the same old faces that we have been meeting all the time. So our intention here is to start using our imagination to try to enlarge this community, to really involve other people on board. And we, for example, have tried to do this today, because on the second part, we have a lot of weight, not from the science part, but a lot of weight from the users part. And we pretend this to continue like that, so we can get enriched on our community, because we have been, if you allow me the joke, being the same group for a very long period. And it is very good if we welcome to this group new faces and new visions from these other sides. So I hope this is a good reply to you, Sebastian. Then June is commented about a positive side of the Coastal Working Group is that we have Bruce ambassadors of BUS, NUS, and IBRUS, in which may existing working groups, for example, the Coastal Working Group, all the different working groups, are already carrying out collaboration. The existing collaboration can be further integrated in the Northeast Atlantic DCC with cooperation between RISES and the Coastal Working Group. I think this is, June, a very good comment. And I have the feeling that maybe it will be good, maybe, and this is really up to this community, that we start thinking about having in each position of the steering team one person per RUS. So we can have, for example, for ocean, the experts on ocean forecasting physics, we can have one expert from Iberus area, another one from NUS, and another one for BUS. And the same in all categories. That could be a strategy to make sure that we have the RUSES properly represented. But also here, try to think out of the box. We have to slowly, and it will not come fast. Try to think slowly out of the box, and try to incorporate also to these steering teams people from outside our community. Not necessarily, it has to be not to be necessarily a reshaping of the coastal working group. We have to think, even if it takes a little bit more of time, even if we say, well, okay, we don't completely close the steering teams now, but we will leave some room for other people to come later, then this is very nice because we can incorporate these other communities that we think. Anna is commenting yes to this, and Sebastian is also satisfied with my reply. So this is great. I think we are right on time to break for a few minutes. If you don't have a very, very short question, then I give you a few seconds to raise your hand, for example, if you have a very... Okay, so here we have another one. We participate in Grubus, BUS, NUS activities. What do you think? Is there a lack of projects and events where we could represent the result of our activities? I think that hopefully let's say the integration of this community in the framework of Dedicate will allow us to enlarge our capabilities to represent in different conferences, in different frameworks. So the question is there a lack of projects and events where we could represent the result of our activities? I think that we have a lot of opportunities, but maybe we are searching for different opportunities to be there, different scenarios to present our work. So Ghada, please, you have your eyes.
Yes,
yeah,
I have everything, my hands and my eyes ready to answer. So thank you. I think, thanks Inga for this question. I think one of the activities that we are going to be doing is actually have a common conferences and events for this community and for this region, organized by different initiatives within the region, as you said. So for you, GOOS is going our BUS or whatever activity or initiatives from the region, we are going to put the events that we know of, and I invite all of you to add those events to the page, to the web page. Then we are all meeting in those events. We are going to go over there. So we can also have a side event to discuss activities for this region. So I think that this is an opportunity to share even those events and the conferences that are dedicated for the region. I would also like to thank June and Sebastian for putting and highlighting the Coastal Working Group. You are part of the Coastal, and Anna as well. You are part of the Coastal Working Group, and I think with our work that we have done in the past, it is the future in a different way. And I think our presence in other regions would be intensified because part of the collaborative center is to work across the regions together with the teams. So I think it would also help the Coastal Working Group as such in bringing back or feeding back opportunities from other regions to the Coastal Working Group and vice versa. So thank you for the questions.
Okay, so I think that we are right on time to do a very short break, and in 5 minutes we will be back. Approximately at 4, we will be back for session number 2. So see you in a while.
Hello, everyone. Good afternoon. I'm Loreta Cornacchia, and I'm working as a researcher at Deltares, and I will be chairing this second session. We will start with a presentation about mapping the present-day situation of the operational ocean forecasting systems in the region. And then we will have 3 presentations about the blue economy impact. So we have 3 speakers from, well, they are users of these existing downstream services. Specifically, they will talk about how they use these downstream services in the context of port sector, aquaculture, as well as in relation with offshore wind farms. There will be time for questions at the end of the 4 talks, but if you have any question in between, you can just use the Q&A box, and then at the end we will go over the question for our 4 speakers. First, we will have a presentation on mapping the present-day situation by Dr. Arthur Capet. He works at the Royal Belgian Institute of Natural Science on offshore renewable energy. And he's been using 3D models to look at marine and coastal ecosystem dynamics. He's as well the author of the first pan-European survey on the operational marine forecasting modeling capacity for the Eurogoose working group. Arthur, the floor is yours.
Thank you. Can you hear me and see the slides?
Yes, yeah.
Okay, perfect. So thanks a lot for the invitation, and thanks a lot for this nice introduction. I was actually going to introduce myself, but we can go. So I was asked today by Ghada and Enrique to present this landscape of ocean operational forecast system in the Northeast Atlantic. And as you said, I think it's mostly because of this work we did with the Eurogoose Coastal Working Group about evaluating the European capacity in terms of ocean forecast. So I will start with a brief history of development of operational oceanography in Europe. And then I'll present the whereabouts of this survey, and then we can start looking together at the results. So until the early 90s, operational oceanography was mostly led by national agencies and regional consortiums, such as ELCOM in the Baltic Sea. Then in 1994 was the year of foundation of Eurogoose, so the European branch of the Global Ocean Observation System. And that has been instrumental because after that, Eurogoose led to a creation of regional instances, ruses that we talked about already, and then thematic working group allowing to push the development of specific aspects. And also it initiated important funding effort from the European Commission to promote ocean forecasting in Europe, with examples just as the MyOcean project, and then the ambitious Copernicus Earth Observation Program. And of course, since 2015, we now benefit from this Copernicus Marine Service, which provide a powerful umbrella to coordinate the development of regional ocean forecasts. A short word about our survey. So the idea was to characterize the European capacity in terms of operational marine coastal modeling. So not only the models, but also the people operating those models, their dependencies in terms of observation and forcing data sets, and what type of data they were provided, how they were provided them, and what phenomenon of interest and what downstream sector they were addressing. And of course, the aim of that was to derive some means of improvement. I will not talk about that today. And we did that by setting up a survey. It was a Google form, and we used the network of Eurogoose and all the rules and CMMs to share this survey through the partners, and this allowed us to reach about 50 organizations and to gather information about 100 operational systems. So before I go on to words of caution, the survey was conducted at a European level, so the entire Europe. So what I will show here is a subset of the survey for, let's say, the Western European coast. And of course, the survey is quite outdated now. It was conducted in 2019, so there's been a few years passed by, and we also never guarantee that we gather all the observation. We do not pretend that the survey is complete. So as we've discussed already, this is typically what will be extended by the Atlas initiative of the DCC. Okay, within this survey, we can differentiate 3 different types of system for the Northeast Atlantic facet. First, we have these 3 regional systems that are coordinated by Siemens, and I will come back to them. So as you see, we have continuous coverage from Gibraltar to the northern tip of the Baltic Sea. Then there's a number of other regional systems that also have a significant extent, spatial extent, but are not operating under the umbrella of the Copernicus Marine Service. And then we have a number of coastal models, coastal applications, which I selected here on the basis of the spatial extent of their domain and of the spatial resolution they were using and what upstream data set they were depending on for things. So as a general, this coastal system that, regional systems, sorry, that are coordinated by Siemens benefit from a very powerful top-down control, the Siemens coordination. That allows a lot of different assets. First, it allows to have a central distribution platform. It allows common standards in terms of data formats, in terms of quality protocols, documentations, user support, so that makes it quite easy for, I guess, downstream user to jump from one product to another. Also, for instance, the central distribution platform also hosts the data that were used to validate this model. So that's very convenient. And I think most important, it means this coordinating umbrella provide a common evolution roadmap. So Mercator Ocean International is coordinating the evolution of the products with specific developments being first tested locally and then considered for uptake at the regional level and then homogenized over the world. So I think this is one of the most powerful assets of this coordination. Just to give you an idea of the characteristics, so we have the Iberian Biscay Ireland area, which so typically about 3 kilometers, sub-hourly resolution for physical characteristic, biogeochemistry and wave have resolution about 3-5 kilometers and are provided at the scale of a day, for instance, for biogeochemistry. Those are assimilating systems. With providing forecasts with 10 days in advance. This is for the European Western Shelf. For now, I'm still using the specification of the previous version, but that will be updated in September, I believe, to match with the Northwestern, with the EB region. So it's also about 1 to 2 kilometer spatial resolution. And then in the Baltic Sea, we have up to down 2 kilometer resolution with similar context and 6-day lead time. What's interesting, if we look at the model engine used by the system, most Siemens systems use the NEMO for the physics, but they are not all the same. They still have their own specificities, for instance, in terms of the model they use for biogeochemistry and for waves. If we look at the other categories, other regional systems, we see there's a much wider diversity in terms of the model engine being used, with systems such as ROMS, ICOMS, or a lot of different hydrophysical models. And if we make a further jump to the coastal systems, now we have, what happens, we have multiple implementation of the common setup, like MOID system or the ROMS setup by Puertos del Estado. Then we have unstructured grid models, and then we also have systems that are nested into own regional models. So if we look, give a look at the dependencies of this model, what they're using for as forcing for open boundary atmospheric and land conditions, most of the Siemens regional models depend directly on the global Siemens setup, on OceanWF for the atmosphere, and they rely on climatology for land forcings. At the regional scales, some models are depending from their own model for the Atlantic region. This is good to know. And on the atmospheric side, there have a good number of models depending on national atmospheric products. So not pan-European SMWF products, but weather forecasts provided by national agencies. And then for the rivers, most are using this EATIP system from SNHI. What's interesting, if you look at what are doing the coastal systems, is that many of them are in fact developing their own model to have access to forcing data set at an adequate scale. So this is true for atmosphere, with operators running their own atmospheric models. And this is also true for land forcing, with many operators running their own catchment model to give forcing data set that are adequate to force such a fine scale coastal models. Because we are the coastal working group, we are interested in the coastal capacities of those models. So this is just to give you an idea of the spatial resolution and shallowest bathymetry that are achieved by this subset of coastal systems. So we see there's quite a good number of these models are with the spatial resolution on the order of 100 meters. So just to wrap up, in short, we distinguish three categories of systems: the regional CMEMS system on the left, that provide a continuous coverage and benefit from this coordinated framework of the Copernicus Marine Service, which provides stable infrastructure. The other regional system, where you have a much wider diversity of model engine and that benefit from national institutions for forcings. And then the coastal models that in many occasions have to implement their own atmospheric or river catchment model to have adequate forcing. Thank you for your attention.
Thank you very much, Arthur, for this very clear overview, nice presentation. And we will see then later if there are questions about this. Now I would like to introduce the next speaker, Susana Pérez Rubio. She's a physicist and meteorologist. She's been working on the field for more than 18 years. She's also part of the physical oceanography division of Puertos del Estado, and there she's responsible for the downstream services and the oceanographic data bank. So she will talk about the port sector services. Thank you.
Thank you very much. I'm going to share the screen. I'll share my presentation. Can you see my screen?
Not yet.
Now?
Yes, now it's coming up. Yes.
Okay. Well, in first place, I would like to thank for the opportunity of showing what we do from Puertos del Estado in terms of operational oceanography forecasting services for the Spanish ports. I think that in first place, I'm going to say some words about Puertos del Estado to give some context and its role in the port sector. Puertos del Estado is a public body depending on the Ministry of Transport, Mobility and Urban Agenda that is responsible for coordination and efficiency control of the Spanish state-owned port system. This system is made of 46 ports that are considered of general interest and that are managed by 28 port authorities. You can see here on the right the port authorities and the distribution. To see the importance of the port activity in the transport and logistic chain, here you can see some figures that say that in Spain, nearly 60% of the exports and 85% of the imports are done through the ports, and that the Spanish state-owned port system contributes close to the 20% of the transport sector GDP, that is around 1% of the Spain's GDP. The conclusion is that the port activity is vital for the national economy, and the port activity, coastal activity, is heavily exposed to the extreme events produced by physical parameters, and mainly wind, waves, and sea level. It is affected, ports are affected in any phase of its life, from the design phase to the construction phase or the exploitation phase, and in the last part of its life. And with this in mind, from Puertos del Estado, since the early 1990s, has been working on producing and customized information based on forecasting services and real-time in situ data. This is done by two main core components. The first one is I'm going to show you the in situ component that is based on networks, permanent networks that provide real-time data. You can see here on the right the map of the stations that are operating right now. The yellow dots are for the buoys. We have 15 open ocean buoys that are moored in open waters and provides meteorological, waves, and surface ocean data that transmit by satellites. We have 12 coastal buoys that are moored in shallow waters close to the ports facilities that provide waves and surface temperature data. And some of these stations have data since the early 1980s. The red dots are for the tide gauges. Tide gauges network started to operate in 1992 and now provides high frequency data. And is made this system of radar tide gauges, but some of them, they also have GNSS sensors, and in 24 of the stations, there is also meteorological sensors installed. The green areas on the map are for the HF radar systems. We have 4 high-frequency radar systems operating right now, 2 of them shared with other institutions to increase coverage. This one here in Galicia, in Portugal, and this one from Huelva to Algarve. These systems provide data since 2010. And finally, we also have meteo stations, 50 meteo stations providing real-time data. Half of them are the ones that are installed close to the tide gauges. And the other half are strictly meteorological stations that are installed in the harbor facilities and that have been providing data since the early 2000s. This information is essential for early warning services, for model validation, and also for climatic and statistical studies to describe the physical environments. The other big component is the forecasting component. Puertos del Estado has been producing and distributing regional scale for forecasting services of sea level and wave forecasts. The sea level service started to operate in 1998. That originally was based on Hamson model, but now it's a multimodal ensemble system that is using the Copernicus marine data. And the wave focus service started to operate in 1995. It's based on Woman Swan model, and it's produced together with the Spanish Meteorological Agency. And more recently, Puertos del Estado has been doing a strong effort to develop and put in operation coastal and port scale downscale model services to produce applications for ports. This has been done in the framework of the Samoa Initiative, and now we can see that we have 17 high-resolution atmospheric system providing forecasts with 50-meter resolution. We have these models are nested to the Spanish Met Office services, 21 high-resolution web systems that in 2 nesting steps reach to 5-meter resolution. These systems are nested to the regional services, the Puertos del Estado, and using mild slope models reach to the 5-meter resolution. And finally, we have 31 high-resolution circulation models that also with 2-step nesting reaches to the 50-meter resolution. These services are originally nested to the Copernicus marine forecasting services. With this core information, we are available to produce, generate tools and downstream services to disseminate this information and, if tailored, information with 2 main targets. On one hand, general public, and on the other hand, the port sector. The general public downstream services mainly are these ones that you can see here, the web page, Puertos, puertos.puertos.es, that essentially collects all the information available at all scales, temporal and spatial. Users can download data, consult statistics, plots and maps. We know that the webpage has more than 8,000 visits daily. And in the last year, the downloading service has had more than 6,000 requests. You can see here on the right snapshot of the application and one of the products. We also have a mobile app application that is freely available on Google Play and Apple Store. That is more focused on the latest data, focused in real time. And finally, we also have the Portoscopia service that is a web-based service, portoscopia.puertos.es, that is focused on massive download data sets for those users that want to download model outputs or high frequency sea level data or radar data. And you can see here how it looked like the Portoscopia as well as the email application. And regarding port users downstream services, these services have been developed within the Samoa initiative. And first one I'm going to mention is the Cuadro de Mando Ambiental that could be translated into Port Environmental Control Panel. That is a tool to support port daily operations. And it's a visualization tool that is focused on the harbor and that displays all the available information and products in an integrated way. This tool is managed by administrators of the harbors. They control the application and grant access to users, activate alerts, define thresholds, and do the basic to managing activity. This tool is available now in 44 ports out of the 46 that have the national Spanish port system. This tool has an additional system that is the alert system that allow users to activate notifications by email or SMS that they can configure easily from the CMA tool. You can see on the right how it looks like the environmental tool, how here you have the real-time data at Algeciras Harbor, or you can display all the information available at the same time. All the data have icons that change color according to threshold definitions. Here you have a map of the latest focus for currents in the Ferrol ports, plots of time series plots for a buoy. Again, the thresholds defined by users or administrators are used here. And here there's SMS from the alert system. based on this case on forecasted information in Algeciras Harbor. Additionally, added value applications have been developed within Samoa to support decision-making in the harbors. I'm going to highlight 3 of them. The oil spill trajectory application that is available at 31 ports right now. Is this one that you have here, snapshots. It allows users to generate simulations, focused and also backtracking simulations of the oil spills. It's based on a mud-slick model. We also have an atmospheric dispersion application to generate also forecasting of the atmospheric dispersion in the harbors, starting from some focal emission points. Users can generate and consult the simulations. It is available right now at 17 ports. And finally, the overtopping forecast service that is available at 4 ports. And you can see here snapshots, the application in the Barcelona harbor. This is complemented with cameras that are monitoring the docks where this overtopping is forecasted, just to detect any overtopping events. And this information is used to validate and to calibrate the tool. After this, all these years of hard work, I show here some figures to see how far have we gone in terms of users and services for our main users that are ports. We have more than 100 models, applications providing daily forecasts. We have almost 100 in situ stations that provide real-time data. We have more than 2,000 users registered in the environmental control panel from ports and connected activities. And we send every day more than 800 alerts, alerts and more than 200 reports to users in the ports. And today somebody told me that we are sending more than 2,000 SMS every month connected with this port services. I think that the numbers are amazing. And just to conclude, I'm going to show how some of the uses that that ports do for our services. How do they use it for? They use our data and services for decision making, knowledge-based decision making. For example, the decision of closing a port due to extreme events like overtopping, to aid in all the piloting operations that are necessary to transport vessels and ships into the port and out of the ports, to have safer and more efficient port operations. For example, the crane operations are very affected by winds, or this information is used for planning the ro-ro operations in the ports. And finally, all the environmental control works use this data, for example, for fighting against oil spills in the interior of the harbors, or controlling the water and air quality in the ports. This is all. Thank you very much. And if you have any questions, I would be glad to answer.
Yes, thank you very much, Susana, for being here and your interesting presentation. I would now move on to our next speaker, Alexandra Neyts. She has a background in bioscience engineering and oceanography, and she's currently senior advisor at EATIP, which is the European Aquaculture Technology and Innovation Platform, as well as a project manager at the Norwegian University of Science and Technology. And she will be speaking about the use of services in the context of aquaculture.
Yes, thank you very much for this introduction. Do you see the screen okay?
Yes, yeah, we see it.
Okay, thank you very much. And thank you to the organizers for putting aquaculture on the agenda. I think that's very nice because it's not always a sector maybe that is linked so much to ocean prediction, etc. So, as being said in the introduction, so I am representing here today under the role of the EATIP, of the European Aquaculture Technology and Innovation Platform. And this is one of the recognized platforms also from other sectors, but we are, EATIP is then representing aquaculture sector and really dedicated then to developing, supporting and promoting research, technology and innovation in the sector. We're a multi-stakeholder, member-based community. It consists of members from both the private sector as the main stakeholders, but also universities, research institutions, NGOs, and associations from the sector. And in addition, we also have regional clusters, which are also industry-driven and member-based, which you can see here on this map. That are all very active in aquaculture, and we are stimulating then the collaboration in between them. So these were a few words about what EATIP is. I also have to add that we are covering the whole value chain, which is important to emphasize, and also to say that not only the production, so because people often think aquaculture is a production of marine or freshwater species, which is correct, but it's also including the supply and the development of technology, of services, of feed, which is also included in the value chain. And of course, we produce food, but also feed and other products from like pharmaceuticals or other marine resources that can be cultivated in the sea and in the rivers. So, and covering a wide range also of different species. So that as background, just to understand that aquaculture is quite complex. So it is very difficult, I think, to speak in one voice about aquaculture, as it is so diverse. But I will try to do so and give you a few examples of what the needs are, in fact, of ocean prediction and models and what we are talking about today. So I can't show you a lot of models and examples. But I will try to focus here on what are the specific aquaculture related focus areas. And when we talk about aquaculture, as also was mentioned in the port, we have two main phases, in fact, two stages that are quite distinct when it comes to the requirements for monitoring. And the first one is the planning phase. So this is really looking into site selection, which is an important part of it, because a lot of marine space, as you know, is already, of course, taken by ports, by maritime transport, by fisheries, tourism, defense, etc. So there is a limited space for aquaculture, and also it has to be, or it has to happen in areas that are considered of beneficial for the species that are being cultivated there. So we are really looking into the environmental parameters that have to be good and not too extreme. That is both for biogeochemistry, but also for physics, like temperatures also, and wave heights, of course, currents, bathymetry is important for the planning. but also risk assessments. Are there any dangers of storms or other harmful events such as harmful algal blooms? And then in the end, it's mostly a socio-economic consideration, whether it is decided if there will be a site there or not. And of course, I also noted here the MPA, so the marine protected areas, which are have been decided to become at least 30% of the area. So one also have to look at the aquaculture. Can it be coexisting, for example, with those marine protected areas, as some parts of aquaculture might in fact be also restorative for ecosystems in the ocean. As a part of the nature-based solutions. So all these things have to be considered. But then when we have a site, we have to look also at the operation. And hence, well, today, in fact, in most of it, it's national authorities or regional authorities that are looking into these issues, and farms have to report on a lot of different indicators. A lot of biogeochemistry has to be reported, and wave heights, etc. So there's a lot of buoys and monitoring equipment around these sites, but they also have to report treatments, for example, the use of chemicals, of pharmaceuticals, if at all in the cage. If there are some escapees, if there are some, what are the fish welfare indicators, for example, and any accidents or harmful events have to be reported. So that is done at the site level, but then if we go a little bit beyond that to the zone level, meaning not only one site, but several sites together, specifically the biosecurity is very important, which is, for example, the spreading of diseases or parasites or pollutive agents from one cage area to another one due to currents and in the coastal zone. So that is increasingly becoming important in order to have a good overview of what is the danger for neighboring sites. Climate change, of course, is impacting to a larger degree also cages when it comes to storms or high extreme weather. And as I have been saying, also the effects on potential effects on marine protected areas. So as I said, also they have to be reported to national or regional authorities, and is also some following periods in order to restore the ecosystem after a production cycle. So these are the two phases. I just want to show you the emissions. Here is an example just from cages where one is monitoring between cages and also across a little bit beyond the cage sites, and where they have to report. And here you see, for example, very small here, but the differences in number of a percentage of sites that are scoring very well or that are scoring poorly in the environmental impact of nutrients and fecal matter in the ecosystem. The same is for lice, for example, or sea lice when it comes to the development. So I think here models would be really important in order to have a better understanding of what the danger is or the impact of aquaculture on the ecosystem. The last example here is where you see the sites of aquaculture on the larger dots here with the different species. And then you see also the small dots that are coral reefs, for example. So more and more information is being collected on it, but what are the real impacts that is still unknown? So this is something I think that will also be important in the years to come. And of course, offshore aquaculture in Norway, we see that there have been dedicated zones for offshore aquaculture, which is quite different than coastal aquaculture, and where we think that the data is even more important in order to have better structures that can withstand high waves and currents. And we have also seen, as the next speaker will talk more about wind energy, but there is also more and more interest through the ocean, the mission for ocean and waters in combining, for example, offshore wind and aquaculture, as is being done within these two projects currently ongoing. Just a small example I wanted to show you is an observational pyramid. I think this is very interesting that we've tried to now link also to aquaculture, where we can really zoom into specific coastal zones, going really into molecular level, in addition to the zooming out from satellites to have better understanding of the impact of aquaculture on the environment. I see my time is a bit running out, but I just wanted to show you this slide on what is happening on the EU side of things, because very importantly, the EU guidelines, the strategic guidelines for a sustainable and competitive EU aquaculture have been renewed in 2021. Here you see in those boxes the targets that have been defined there. But they are now being implemented through the aquaculture assistance mechanism, also through national strategic plans and funding opportunities. But I just wanted to refer to you the aquaculture assistance mechanism, where you see the different parts of it as providing a repository for guidance documents, also for best practices and projects. And I think a lot of the models and of the issues that you have been talking about also could be included in those in the guidelines that are currently under construction here, and where also EATIP is providing and closely collaborating with the Commission on providing those. So, I mean, yes, aquaculture is very much into the digital ocean. It has already, as you see in this picture, taking on a lot of monitoring equipment to have a better overview and a science-based decision-making, also at site level, at industry level. And we have, of course, I'm sure a lot of things are missing, and I'm not a specialist in this, but I just wanted to show, okay, I understand that there's a lot of good things and data services out there, but there's still a lot of work to be done. I think when it comes to increasing awareness about the value of these data services to support the aquaculture sector. And I know we are also involved in some of the projects where aquaculture is being looked at an application area with promising results. And also, for example, where the industry itself has been the initiator of data and services that are being promoting best practices and monitoring, monitoring for their raising awareness, and also looking into better practices. For example, with the allocation of zones for aquaculture, through an easy-to-use tool for calculation of product environmental footprint, and perform fish benchmarking systems. So these are all promising examples. But for the end user of a sector that is mainly dominated by medium, but maybe mostly by small and micro enterprises, we think it might be difficult to understand the added value of these applications always, and to implement it in their daily businesses. So it's easy to get lost, I think. It's easy to lose interest, maybe also from the end user side. And one should probably be aware in order to avoid this, and to get them on board really in order to promote the co-creation we all want to be part of, to promote. So with this, I finish here. Thank you.
Thank you very much, Alexandra. A lot as well to think about and discuss. later after the presentations. And this connects also very well with our last speaker, Dr. Nancy Nevejan. She is also an expert in aquaculture. She's a lecturer and head of the mollusk group at Ghent University, and she specialized in aquaculture nutrition and bivalve hatchery production. But she has also been involved in the last 10 years on shellfish farming in the Belgian part of the North Sea, and she has been working on different pioneering projects like United and Old Farms, which also link aquaculture with offshore wind farms. So the floor is yours.
Thank you very much, Loreta. I will try to use the time that is left as well as possible. So let me go and share my screen. Okay. So thank you very much, Ghada, for inviting me to give a short introduction or a short presentation on our experience and how we feel through our experience, field experience, I should say, how we feel modeling can help us in the future. This presentation is made by myself and by my colleague Brecht Steggele. So we both work for the Laboratory of Aquaculture at Ghent University, and we do have some experience in offshore aquaculture. So our lab
Nancy,
is...
sorry, can you please put it in presentation mode?
Oh, is it not yet in presentation?
No, not yet.
Is it okay now?
Yes.
Oh, yeah. Thank you. Sorry. So the ARC or our lab has some experience with offshore aquaculture. Just very briefly, the Belgian part of the North Sea is a very dynamic environment where we have currents of 1 meter per second and where we have a wave climate that is quite challenging. We can have storms with 12-meter wave height, and they are not occurring every 50 years. We see that they occur on a shorter time lapse as the years go by. So one of the first experience, I should say, with our offshore aquaculture is the project EDULIS that was funded by the European Fisheries Fund, where we try to grow mussels within 2 wind farms. So we have the wind farm of Belwind and Sea Power. So just to give you an idea how the structure looked like, it's a pilot. So it was a very short backbone line of 58 meters. But we were quite lucky, I should say, that at that time already the wind farms were open for experimental work, and so this was a very good, I should say, teaching school where we learned how we have to design our systems. What are the how do we have to prepare ourselves? How do we need to do the monitoring? Because we are working within a wind park, so we had to avoid any risk. So risk management was very high in our agenda. So we had 2 lines, one which was focused on the growth of the mussels, and the other one was more focused on collecting in situ data on the forces that were acting upon such a long line. Because at that time, we knew, well, through hindcast calculations, and so we knew how the hydrodynamic conditions were globally, let's say, in the Belgian part of the North Sea, but it was very hard to predict how these would act upon our long lines. Based on the EDULIS project, we could then, we were part of the current project United. It's a Horizon 2020 project, actually coordinated by Deltares and Ghada. So the ARC is responsible for the Belgian pilot. Again, we have an operational phase within the wind park of Belwind. And here we are looking into a combined production of seaweed and flat oyster within the wind farm, but we are also looking into restoration of flat oyster reefs in the wind parks, making use of the scour protection. So just some pictures to give you an impression on the activities that we do. So you see that at least we are testing the systems near shore. So we could see that the system was working very well near shore for the seaweed production. And this year we were also collecting seaweed from our offshore site, which was also much better than we anticipated. So that was good news. You see here the cages that were put on the scour protection to support our restoration efforts. And to the right, you can see that this is the backbone with all the oyster production systems or culture systems that were put within Belwind. And then thanks to the United project, we actually made a good case, and we were also granted a follow-up project, a Horizon Europe Ocean Mission project, Old Farms, again coordinated by Deltares and the group of Ghada. And again, the ARC is there managing the Belgian pilot. And here we are focusing much more on the growth of low trophic aquaculture species, meaning in our case, a combination of blue mussel, oyster, and seaweed culture. Just to show you that we have a little bit of experience, at least with offshore aquaculture. And for sure, this would not have been possible if the models were not there. Because if you're working offshore, there's no means of collecting a lot of in situ data. It's very complicated. So we had to use models to forecast the hydrodynamic conditions to help us to design our systems. So how would I say? We needed modeling, we needed models, for example, to plan our marine operations, because we are, of course, very weather dependent. So the weather forecasting is not only important for the wind farms, but since we are working in a kind of a multi-use framework, the weather forecasting was also very necessary for our aquaculture activities, especially if you're working in a wind farm. The restrictions are very high. So for example, we cannot do any aquaculture operation if the waves are higher than 1 meter. So that is why the weather forecasting was very important. For now, we are relying actually on the regular weather forecast. So there is no, how would I say, there was no specific program or no specific weather forecasting model that we were relying on. So it was just the public one that we were using. And then of course, in combination with the tides, we kind of planned when we would go to the sea. We were also using models to predict the forces that would act upon our long lines. We relied on commercially available products, but at the end, we were designing our own model, which we called Moordin-Huygens. And of course, the Copernicus data also helped us to provide us with data on the chlorophyll and on the temperature, which in turn allowed us to model or predict the growth of the aquaculture species that we wanted to grow in these particular areas, and also to predict the growth of the species that we wanted to restore. As in our case, for example, it was the flat oyster. So also based on this biological data, it helped us to define the suitable habitats, for example, for future oyster bank restoration. So definitely without without the collection of the data and the models that were already existing, we could not have done our aquaculture operations offshore. But of course, I was also asked to define maybe the gaps and the needs from our practical point of view. And so I decided that, we actually made a kind of a wish list. We understand that probably I'm asking for things that are very difficult to implement, but at least in an ideal world, these are some of the requests or that we would like to see fulfilled. For example, what we were always struggling with is that we would like to see a longer prediction window for our marine operations, because it did happen really that we had to cancel an operation one day beforehand because the weather conditions were suddenly changing. Or also we were planning, but then for almost 2 weeks or 3 weeks beforehand, we were never sure whether we would really be able to go out or not. This complicates, of course, very much the planning, because you need to find and hire a vessel to do your operations. So you are setting yourself a particular time window. But if at the end, after 3 weeks, it turned out that, or within 2 weeks, it turns out that that week will not be possible, you already made your engagement, you already have to pay mobilization costs, and these costs for these vessels really go sky high. So now and then we lost quite an important amount of money because we had to cancel vessels because we could not predict the weather in advance. Also, extreme weather conditions, we would like to see them predicted. So, for example, in future, when we think about commercial aquaculture systems offshore, operators would have the time to change the system, for example, by lowering it more to the bottom so that they would be less submitted to the forces of the waves. So if that would be possible, that would be a very nice tool. Also, since we are very much involved now with nature inclusive designs and nature restoration, restoration of oyster reefs and other biogenic reefs, we are very much looking into connectivities between coastal areas or between offshore locations. So that means that we need we need to understand the hydrodynamics on a very small scale sometimes. So we would need smaller resolutions, both in time and space, for a better understanding of that connectivity. Mapping of stratification and sediment type and the stability of the sediment floor would also be very useful from our point of view for aquaculture and restoration purposes. Data on biological aspects would include, for example, a better understanding of the distribution of the phytoplankton in the water column. That would allow us to identify areas where, for example, there is enough food for our bivalves. And also ecological data, for example, which species grow where, could also be, would be very interesting. I know I'm asking a lot, but this is just, some ideas that we have. And then, of course, if you look into linkages, the prediction, we would also like to see that we can predict the forces that will act upon the system, but also in function of the growth of our aquaculture species and in function of the fouling cycle. Because of course, our long lines get heavier as the animals are growing. Summertime, we have more fouling than in wintertime. So if that could be incorporated in the predicting models, that would be fantastic. And also, we feel that it would be very good if if we identify good locations for aquaculture species, that these would also be translated into the maritime spatial plans. So we see there a very essential gap, especially if we want to make it more user-friendly or if you want to produce tools that users can use. And then also the translation of the hydrodynamic characteristics into technical requirements for the aquaculture systems, for the vessels, for example, that would also allow us to be more flexible, to, for example, decide which kind of vessel do we need for a specific aquaculture system, and it would also, of course, increase safety and reduce probably also quite reduce the costs. So this is more or less what I wanted to say in a nutshell. Concerning the services, we would think that better basic data instead of pre-made tools that mention also the minimum and the maximum values and not only average values would be very useful for us. And then, but that's actually the aim of this platform, is that the data are shared with open access. And of course, and also make sure that the data sets are coherent is of course a precondition. And then another possible very useful tool would be that we can have the data on variable resolution so that the user can also decide which resolution he needs for his specific application. So this is in short what I wanted to share with you. I maybe went a little bit too fast, but I wanted to share at least all the thoughts we had in the limited time that was appointed to me. But thanks very much.
Thank you, Nancy. It was very useful to also see your needs and wish list to be shared here. And thank you all our speakers. Because we're running a bit behind schedule, I invite you to check in the chat and perhaps reply by text to the questions that came up. And I would then give the word again to Enrique.
Thank you very much, Loreta. Yes, I think we are a little bit delayed, so it will be good if we go for the interactive session. You have on the chat the Slido to, maybe you can, Vincent, share also the Slido on the view share screen, so you can see the link and the number to the Slido. So what we will do is we will have, I hope, a nice time. It was a good experience with other regional teams, answering the questions that we have sent to you in advance on the calls for this meeting. And only one comment that we learned by suffering it on previous exercises is that please limit your reply to only 3 words. Don't use long sentences, because if you use long sentences, then the Slido starts to break the sentences into pieces, and it's impossible to reconstruct. So, Vincent, maybe we can go with the first question of the poll, and I'll give you some time to answer this one. Please, since we are a little bit late, try to hurry up on the replies. And even if I pass to the next question, you will have more time to add additional replies. So our first question is, which are the main applications that ocean forecasting is having today on the region? So we have one, maybe from Susana, saying ports. Maritime safety is popping up. I have to say that this was a really nice meeting, in the sense that we had a good representation of the users. Obviously, it's a limited representation because there are many more users for our systems. But this is also a message that we want, again, I repeat, to go out of our usual environment, to go out of our usual faces and reach outside and attract the users to our community. So let's see what answers are being hopping. Let's see what we have. We have ports, we have maritime safety, extreme events, so things waves. Please use only 3 words if you can, because if not, we have this problem of your contribution being split in many words, and it's very difficult to reconstruct. So if you can only limit to 3 words in order to have it manageable. So we have early warning system. So things related, a lot of things related with risk, extreme event warning, disaster risk reduction, risk, early warning system. So it seems really here the main input. To give you an example, in other regions, like for example, in Africa, there was a lot related with fisheries. Here it's more about risk management, multi-platform offshore shipping, storm surge, which obviously is again related with risk management, port operations, linked to the ports again. So really, most of the inputs, okay, we have fisheries with a smile. Thank you for that one. Most of the things are related with dynamic risk reduction, I think, and also with marine safety and search and rescue, which are quite important. So it's not very surprising. This is, at least for me, because it's my natural background in Europe, so is the well-known replies, I would say. Okay, you can keep on. Well, there's a nice one here. Science, it's an important one. We cannot forget about this one, because this is very important. Climate change impacts. That's another family of application, those related with the study of climate change and the impact of climate change. Some surf also there. So sports are also important. 2 more participants typing. Please, for next one, remember all these 3 words limit, so we don't have renewable energy, which is surprisingly not appearing more, because this is becoming more and more important. And I'm sure that in 10 years, that will be probably, if not the first one of the most important. So ports are really important as a final keyword. So let's go for next. Please keep on going, but I'm not going to stay longer because we are already delayed from the end of the meeting. So let's go to next one. Which are the main gaps for ocean forecasting today in the region? So if the whole ocean forecasting value chain, when you reply this one, for example, or think about maybe it's resolution, maybe you can think about coordination. Okay, resolution immediately pop up. This is a very common one. Seasonal forecasting, that is a good one. We don't have many activities related to seasonal forecasting. This is true. Climate projection, we have activities on that, but it's true that we need more of that. Observation, that's the other classic. Obviously, in every region, observations are not sufficient. Sometimes for the validation are not sufficient for the data simulation. Spatial resolution and time sampling. Again, we go with the resolution. Real-time validation, linked with observations. Wave current interaction. This is absolutely correct. We don't have, except maybe, of course, the Copernicus system does have this, as let's say the most advanced systems around. But when you go into the coastal system, most of the system does not have this wave current iteration that can be very important. High frequency processes also linked with the same. Coastal altimeters, that's a very good wish list to have valid data of the coastal altimetric science near the coast. Assimilation at the coast, yes, this is something we are missing. We have some experience with HF radar, but not really extended and not really common. And I will say that even we don't fully understand yet at what point assimilation at the coast is absolutely mandatory, and at what point assimilation at the coast is not having a good impact due to the small size of the domain. So there's a lot of R&D to be done in this field yet. Coastal processes, variable resolution, that's important, linked to the resolution. Like resolution, so resolution is in different flavors, quite common. And it's interesting to find out that a classic one is not popping. Please don't write it because I say it not, but I don't see a classic one, which is very good news because it seems that we are improving in this one, which is bathymetry. If you remember, we do this exercise 10 years ago, bathymetry will be in this list for sure. Now we have rivers, which is the other usual suspect, but bathymetry is no longer on the list. So it looks like the works done in Monet and in other places are paying, but I guess that somebody will write bathymetry now that I mention it. I can bet about that. So rivers are there, real-time lab discharges with different words, but rivers are in several places. So I think this is a very good summary. Biological data, this is and biogeochemical data, this is an absolutely lack. So thank you. We are forced to move forward because of the time, but I insist you can keep on typing, and that will be on the minutes of the meeting. We pretend to do minutes of this meeting with all these beautiful word clouds and all what has been said. Let's go to the next question, please. Which are the activities you think OceanPrediction DCC should focus to improve the situation of ocean forecasting in the region? So help Ghada, help us to analyze, to steer this, and start paving the way for the future of our activities with this. So land-sea continuum, I guess this is related with seamless prediction and the importance of the rivers and differentiating between the coastal and the deep sea environment. Co-design, this is very important, and this is exactly what we are aiming to do at the Ocean Forecasting Co-Design team. So retention in fjords, I must confess, I don't know what is retention in fjords. Coordination, that's a good one. Coordination is gaining some importance. So again, this land-sea continuum. Fisheries and aquaculture, so I guess this is making a special focus on this part. Ensemble simulation. So in these very technical things, what we are doing, what we are planning to do is exactly what is being mentioning now, like best practices sharing on this one. So the idea with the Ocean Forecasting Design team is that during, we hope to deliver early next year, potential architectures for the future of the operational forecasting systems that will allow us to have better interoperability and better systems in the future. So what we are going to detect is which are the tools, standards and best practices that must be developed during the decade in order to reach this new scenario. So this is the key of the technical part we are doing. Strengthen the link between models. I guess this is also related with exactly with what I was saying. Interoperability, I guess, the ability to deliver as one, as we call it. Know-how sharing. We have these activities that we will develop in capacity development. I really think that we need to count with this regional team for this capacity development, not only to receive capacity development in Europe, but to spread the voice in other regions that are less advanced from the technical point of view. Knowledge share is about the same thing. Hybrid modeling, again, this is technical. I go to that. Rip currents, this is technical. Again, architect value chain, this is exactly what we are trying to do on the Ocean Forecasting Design team. So resources for research and development, this is a little bit maybe beyond our capabilities, but it's nice to see it. Maybe helping to lobby in this direction could be perhaps a better phrasing of what we could do. So let's go for last one, because we could stay here for more time, but we are late. What kind of capacity development and ocean literacy activities do you believe are needed in the region? We are asking this because we need your help in this particular point. One of the objectives that we have for this year is to build our plan for capacity development and ocean literacy to be implemented in the following years. So we would like to have your vision here to help us prepare this document that we will deliver by the end of the year on how we have to steer our ocean literacy and capacity development activities in this particular region. And also consider that this particular region has to be a focus of, let's say, teachers for other regions. So I would like to extend this question for this particular region, saying how can we receive activities, but how can we participate in activities outside Europe? So general public awareness, this is more related with ocean literacy, ocean reports along with meteorological, that is again related with ocean literacy, trying to convince TVs and other media to do that. Teacher resources, that's exactly what I was waiting to have here. Theory practice link. So yeah, that is nice to have something more in the courses, in the activities that we are going to do, so to have activities that are hands-on, that people can really learn by practicing. Public demonstration of services, economic accounting of ecosystem services. Okay, economic accounting is a big challenge. We have tried, I have seen several attempts, but I think in general there's a communication problem between economists and oceanographers. And at the end of the day, the outcomes are usually not very easy to get and not very useful for the oceanographers. So this is a good point, and some area where really good works are still needed to be done, and some research is needed to be done. Citizen science, this is a good one, and an important one, and linked to the general public awareness, the communication of uncertainties. So very much of this is related with ocean literacy, our capability of being influential in other sectors of the society, thanks to communication. And it's not that much related to capacity development in many cases, except a few ones like teacher resources, which is quite focused on that. Operational oceanography in support of blue economy is a topic, again, for ocean literacy, I believe. So the main concern is about our ability to connect with the society, I think, because I see many things around that. Public demonstration of services, support of blue economy, general public awareness, all goes in the direction of we are not being able to connect with the society. Reach out to other communities could also be understood like that. So there are a lot of things related with ocean literacy here. Okay, so I think that this is it for this one, and I think we are done or we have a fifth one. I don't remember. Yeah, there's a final one. Okay, observations. Now is our time to express how important observations are and to declare our need for maybe you think we have enough observations, but do you think observations from the region, if available, obviously in this region are available, are sufficient to constrain the ocean models and produce accurate forecasts? If not, what kind of observations are we missing? So I guess that if you suggest additional observations, is because we are missing this one. Coastal autonomous profilers, that will be extremely useful for biogeochemical, is immediately popping because we have very few biogeochemical observation. Again, altimetry in the coastal zone is desired. No coastal profiles again, so coastal profiles are obviously very important. Not enough current observation, absolutely true. Very limited current observation, a part of the few HF radar systems available, but in terms of traditional current meters, the number of operational current meters available is, let's say, ridiculous. High resolution CIs, it's not my field of experience, certainly, but I believe it. Observation value showcasing. Okay, that's an interesting one. We have to, and it's linked with previous one, we have to demonstrate the value of observation if we want to get the money to have more observation. I think that's a very smart one. Deep currents, which we have very little thing about that. Benthic fluxes, very little thing again about that. Satellite products for waves in the North Sea. Okay, that's pretty specific, I would say. And river data linked with, yes, that's an important one, linked with the gaps that we have seen before. We need river data in order to improve our systems. We don't have enough subsurface information, so I mean, it's not strange that everybody's replying, yes, we don't have enough information. Nobody is satisfied with the observing system, which is nothing that can surprise us. So I think we have a good variety of things here. Mainly, they are focused on subsurface observation, coastal autonomous profilers, and other things, mainly related to underwater measurements. Please keep on writing your replies, even if we finish now, because we are already quite delayed. And I give the floor back to Ghada. So as chair of this team, she can finish and say the final words on this meeting. Thank you to all of you for being here and for your participation on this Slido experiment. Thank you.
Thank you, Enrique, and thank you all. I hope you can.
You're muted.
No, I'm not. From my side, not. So thanks a lot, Enrique, for this event and for all of the questions. I think the answers to those questions will help us shape our activities, our plan, as have been highlighted today in the morning and very early of this meeting with Pierre. And there are a few things that we are going to be actually doing, sending you the role of the steering committee. I have been having questions from people interested in the role of the steering committee. So we would send that out, and maybe the expertise that we are looking for. And please do consider, send us an email, and then we can discuss that internally and see who's going to be where. And all of you are very much welcome to be part of the steering committee if you wish so. And there is also another meeting that has been proposed that would be really nice to have a meeting together after the summer, because we are all going on summer vacations very soon, just after this meetings, that we have a meeting to discuss the activities, what we would like to do in the light of the objectives for this regional team, and what we have suggested, and what you suggest, and what you would like to do from this. So for that, I wish you all a very nice evening or rest of the day for the rest of you, and really have a very nice sunny summer vacation that we all need at this stage. And thank you, Enrique. Back to Enrique for the last words, if you wish.
No, thank you. That was perfect closing. Thank you. Just saying once more, thank you to all of you for being here. And we are on track, and I hope we are going all to have fun, and we are getting good results out of this experience. Thank you.
Thank you. Bye, everyone.
Thank you. Bye-bye.
Thank you very much. Bye.
Bye. Nice holiday too.
Oh, we'll need the tree.